Hi everyone, I'm Jon Bruner. I work for O'Reilly, a publisher that some of you probably learned to code through. I'm an editor at large there, which is a title that I invented and they were kind enough to give me. And last spring, I wrote this research report about the industrial internet and spoke about it at this meetup, sister meetup, the data business meetup that Matt also runs. And the industrial internet is sort of about the spread of internet architectures and models and technologies into heavy industry and places where it has to be robust, places that used to use all sorts of proprietary technologies, but that are now warming to the way that things are done in software. Since I gave that talk, we've seen a lot of interesting things happen in this crossover space between software and the physical world. Google has made a bunch of really fascinating acquisitions. They bought Dolly, which is a robotic cinematography outfit that's just extraordinary. Boston Dynamics, which is a defense robotics company that makes this amazing thing called a big dog that runs like a dog. And of course, yesterday they bought Nest. We saw PCH, which is a giant supply chain company, fulfillment operation, manufacturer in China, which normally does this sort of thing. Start a new incubator in San Francisco called Highway 1, which is premised on the idea that a lot of people are coming out of software and moving into starting to build hardware and need to navigate the complexities of manufacturing stuff and developing stuff and marketing stuff, which is all very different from the way it's done in software. Of course, we were all transfixed by this in December. Everyone seems to be getting into robots. So those are companies that have generally gone from software and are getting into hardware. We've also seen heavy industry reaching out and getting involved with software. Earlier this year, GE spent $105 million to buy 10% of Pivotal, which is an effort to bring the kind of big data technology and mindset that's common, mostly in advertising, into applications that have to do with machine data. So analyzing things like sensors on jet engines. And on a much smaller scale, we've seen companies like Ford make acquisitions as well. They spent about $10 million to buy Livio, which makes software and hardware sort of integration components for connecting your smartphone to your car. So in all, we've seen this incredible acceleration and convergence between software and hardware. Both software companies reaching out into hardware as a way to extend the software they're working on, and companies that have traditionally built stuff paying much more attention to the software that runs on. And also earlier this week, I think, Google announced a partnership with all of these automakers to start to put Android in cars, which is a big deal. If you talk to an automotive engineer like 2 years ago, they say that Android would never run in a car, that it's just like, it's crazy. Open source software is developed by people in their underwear in their mom's basement, and it will never run on a system where robustness is important. It's a big shift. In response to this, we've, as Matt mentioned, launched a new conference, which will be in May in San Francisco. This is my co-chair on the conference, Jody Ito from MIT. If you go to the webpage, you'll see JavaScript render his face in and out of my face, like identical, bringing up into the right photos. So a handful of the sort of conceptual underpinnings of what we see going on. The physical world is starting to look a lot more like the software world. Physical devices can have these software APIs available, which make them extremely powerful and very easy to start using. You can control, the Arduino is the most familiar example to a lot of you, but it's quite easy to hack automobiles, to develop software interfaces for things like home appliances, and there's a lot of both reverse engineering going on and developing new things based on this kind of concept of API brought into the physical world. So in the same way that the internet has the social graph or the information graph, there is a rising physical graph, which is Alex Hawkinson's term for it, and the original name for the company is SmartThings. There are big changes happening in how things get manufactured. even mass production manufacturing in China, aside from the kind of 3D printing that we heard about earlier. Amazon Web Services completely changed the way software gets developed and deployed by making it possible to create software and put it out on a large scale without much in the way of upfront capital. You didn't have to buy your own servers and buy your own software licenses anymore, just pay on a monthly basis. Models are coming along that let you do the same thing with manufacturing. I mentioned PCH earlier. There are a handful of these sort of supply chain companies that are willing to create a capital light model for producing something new in the way of hardware. And that's going to really change the way that people develop hardware and dramatically lower the barriers to entry in hardware. And one other thought, I completely forgot. We see a kind of new merging of software and hardware. People who deal in the physical world have been jealous for years of the kind of intelligence available to companies like Amazon and Netflix that they get when they watch their customers. This sort of thing with pervasive networks and extensive sort of sensory and data gathering now becomes available to anyone who is developing a physical product instead of a web product. Your microwave oven can monitor usage and understand you in a way that previously only Netflix and Amazon and web companies could, by observing your usage patterns, observing the life cycle of the device, and transmitting the data back to the manufacturer. At the same time, it lets improvements run the other way. As Jeremy just mentioned, you can have a physical device that gets better over time, which is just crazy. I mean, Tesla does this, and it's one of the things that most delights Tesla's users is that your car, while it's parked overnight, gets a software update, and then it gets 5% better range on its battery. This is the sort of thing that used to be unthinkable in hardware that was very common in software in the era of software as a service and web software that's now coming into the physical world. And the result of this is that every company has to understand software and organize itself like a software company and figure out how software is going to affect its business. As software gets more closely connected to both machines, as software gets more closely connected to machines, it's more important for companies to understand software in terms of both how it's integrated with machines and how the machines are produced. You can replace the boundaries between software and physical devices are becoming much more fluid. It's getting easier to cross back over them by instrumenting physical machines. And so you can take complex physical devices and replicate them in software. It's much easier to move bits than it is atoms. And so in a modern car, for instance, you see the radio, the thermostat, the anti-lock braking system, the airbags are all basically software-defined systems that run on something like a computer in the car. And that allows the car maker to go back and sort of update the system after you bought it. It also means that the device keeps renewing itself every time that software is refreshed in it. And if you're, say, a car company, you can monetize that through like lease sale apps. The resale value of the devices you're making goes way up when you can improve it along the course of the machine's life. As it becomes easier to deal with hardware, it becomes easier for new sort of populations to get into hardware and deal with hardware, and things that used to be very restricted to people with certain kinds of expertise are now available to anyone. In the same way that you can build a website by like sitting down with an O'Reilly book over a weekend and learn a little bit of HTML, it's now possible to do the same thing with something like a microcontroller, which is just crazy. All of this permits you to offer the physical world as a service. Not only services like Uber or the eventual sort of driverless car Uber that come about when you instrument machines and measure them, but also you can quality of services rather than the sort of simpler ways of doing things like heating a building that we have now. Right now, you own a furnace and you buy gas from the utility that heats your building. Once you instrument everything and create networks and make everything intelligent, you can do something like providing heat instead of providing furnace and gas for it. The utility can guarantee that your house will be between 68 and 70 degrees every day, and then you pay for that as a service. This allows you to take advantage of differences in cost of capital and economies of scale that happen when, say, a big utility operates a bunch of furnaces rather than individual owners. And this creates a lot of really interesting problems with respect to design, which has to move beyond an era of looking through screens. So a screen and a keyboard no longer mediate your relationship with the computers around you. Instead, they read your location through through the sensors in your phone, and then make some understanding about what you're doing and what your preferences might be based on that. You never have to pull out your phone for Google Now to remind you that your appointment is starting in 27 minutes and it will take you 23 minutes to get there, so you should leave now. You think of all the different layers of screen-mediated interaction that you go through to do something like find a sushi restaurant and go to it. You probably go to Yelp, look up sushi restaurants in the area, find a sushi restaurant, retrieve the address from it, put the address into the GPS in your car, read the directions back out of the GPS, and drive your car to the sushi restaurant. All of that can be collapsed down into the same stack and have in the background, and that stack now goes all the way down into your pocket, into your phone, into the systems in your house. It's extraordinary. So, oops, I didn't miss it. That was the last slide. So, thank you all so much.
Thank you very much. We're going to have pizza soon, so this is any questions for John Gill?
Sorry for me from the New York City Economic Development Corporation.
Here from the New York City Economic Development Corporation, very interested in the city, EY's manufacturing. Could you talk a little bit about the conference that you're holding, what the purpose of it is, what are you looking for bringing these people together?
That's a good question. So the conference is about the collision of software and the physical world in every respect. And O'Reilly's sister company, Make, has an event called Maker Fair that probably a lot of you have been to, that's oriented toward hobbyists. And the idea here is that a lot of things that are sort of growing out of that movement and into the commercial and industrial applications. So you can think of it as a Maker Fair, but above the hobbyist level. The idea is to create some interaction between the software companies that are fixtures in Silicon Valley and the kinds of hardware and industrial companies that are a little more foreign there. So to create some dialogue between those and develop community in both directions around both the physical, the manufacturers who are moving into software and the software companies that are moving into manufacturing.
Some of the most interesting companies, usually startups that you've seen recently, sort of non-obvious Nest or anything of similar?
One of my favorite has been a company called Sight Machine, which is based in Ann Arbor, Michigan. It's sort of an unconventional place. And O'Reilly's VC firm is an investor in Sight Machine disclosure. Sight Machine provides quality control features for heavy industry, for car manufacturers, and a few other applications. They use nothing but webcams, which is an extraordinary sort of advancement in the way that sort of thing is done. So that all of their entire, the value of their system is really the software behind it, which runs as a web service. So one of their clients encountered this problem where 1 in 500 cars that runs off the assembly line has like the wrong badge on the back. It's the deluxe edition, but instead it says like, you know, super deluxe edition on the back. And what happens is the car makes it all the way to the dealer finds the error, it's going to cost us thousands of dollars to send the car back to the factory and have the badge taken off and reapplied. So their system photographs every car and checks the exterior and interior features against the purchase order for the car. And it does all of this with extremely basic hardware. It interacts with the cars through computer vision, which is a really promising, foundational part of this whole area. Instead of a web screen, it's sort of world screen technology like that.
All right, well, thanks very much, John. We appreciate it.
Thanks.
And so that's it for the talking part of the evening, but now we're going to get started on the pizza part of the evening, which is over there. So thanks to all our great speakers. And so the next one, as I was saying in the beginning, for those who missed it, is going to be at Corky on February 19th. So thanks and see you guys.